So for questions 1 through 3, we're going to solve each exponential equation. The easiest way to do it is to get like bases so that you can cancel out the bases. So looking at question number 1, the right side over here with the 5 can't be simplified any further because 5 to the first is just 5. But I can, however, take this 125 and rewrite it as 5 to the third power. Because 5 to the third power is 125, I also have to leave the negative x minus 2 up in the exponent where it was located. So doing that gives me like bases of 5s on both sides, which means I can cancel those 5s out, leaving me with 3 times the quantity negative x minus 2 equals 1. Distribute the 3 to get rid of the parentheses, so negative 3x minus 6 equals 1. I would add 6 to both sides, so negative 3x equals 7. Divide both sides by negative 3, and x equals negative 7 over 3. We just move that negative to the top because we don't like it in the bottom of a fraction. Question number 2, in this case, we have bases of 36 and 216. We cannot rewrite 216 to be a base of 36, so we're going to rewrite them both. Well, when I look at 36, it automatically stands out to me that 36 is 6 squared. Leaving the 2x plus 2 in the exponent, we're going to see if we can rewrite 216 as 6 to the something power. In this case, it happens to be 3. Since our bases match, we can cancel them out, leaving us with 2 times negative 2x plus 2 equals 3. And again, we're going to distribute, so negative 4x plus 4 equals 3. Subtract 4 from both sides. Divide both sides by negative 4. Negative 1 divided by negative 4 is positive 1/4 because the negative divided by negative is positive. For question number 3, I know when I look at 3 that I can't rewrite 3 as anything else. So I can't rewrite the left side. I'm going to have to rewrite the right side. So looking at the right side, I have 1 divided by 9. Anytime we deal with that fraction, we want to look at the denominator and figure out, in this case, 3 to what power is 9? Well, 3 squared is 9, but since it's in the fraction, we're going to make it negative. So since it came from the bottom of a fraction, we have to make that exponent negative. So now we have like bases, we're going to cancel them out. So 1 minus 2p equals negative 2. Subtract 1 from both sides, so negative 2p equals negative 3. Beside it, divide it. Divide both sides by negative 2. And p equals 3/2 if you convert it to a decimal 1.5. So all 3 of these on your test worth 2 points apiece. 1 point for rewriting it, 1 point for solving it correctly. Questions on these? Question number 4 tells us that the problem below was solved incorrectly. Describe the mistake and find the correct answer. Anytime I give you a question like this, I do not suggest you look at their work. I suggest you take this and you solve it out to the side before you look at what they did so that you don't make the same mistake subconsciously. So looking at that, we want to get like bases. So we have 3. I can't rewrite 2 as anything else, so I'm going to leave it as 2 to the power of negative 3n plus 7. However, on the right side, I can rewrite 8. 8 can be written as 2 to the third power, and the 2n stays up there in the exponent. Now I have like bases of 2's, I can cancel them out. So negative 3n plus 7 equals 2n. Oh, not 2n. I lied. 6n. So I have to multiply these together for 6n. Now I'm going to add 3n to both sides. When I add 3n to both sides, that gives me 9n. If I want to get n by itself, I'm going to divide by 9, which gives me 7/9. So my correct answer is 7/9. Again, I would just leave that as a fraction. Now I want to go back and figure out where the mistake happened. So I'm going to look at their work, I'm going to look at my work, and I'm going to compare where I see something different. In this case, it happens to be in step 1. So in step 1, the 8 to the 2n should actually become 2 to the 3rd power, not 2 to the 4th power. So tell me something about in step 1. Oops, that should be it too. Oh, man. So something about how that 4 should be a 3. You could tell me that 2 to the 4th power is not 8. 2 to the 3rd power is. This question is worth 4 points. 2 points for you describing the mistake. 2 points for me being able to find your correct answer and your work that goes with it. Questions 5 and 6 on the back, we're giving you either a logarithmic equation or an exponential equation, and you're converting to the other. So for your test, I'll give you a reference sheet that has the conversions on them. But for now, here they are. So these are the 2 conversions. You can convert one way or the other. So the first thing I want you to do, especially when you get to your test, take your time to label things. So we're going to label, in this case, the 15 is the base, m is the y, and negative 18 is the x. So we want to rewrite this as b to the x power equals y. So that would be 15 to the negative 18th power equals m. So I'm going to look down through my answer options to find letter B that matches exactly. And I'm doing the exact opposite for question number 6. I'm going to label this time the exponential equation. Whoops, I wrote that backwards. No, did it? Yeah. So b to the x power equals y, and then I want log with a base of b. So log base 8 of y, which happens to be 1 over 64, equals x, the exponent, negative 2, which is answer letter D. These are both worth 2 points apiece. They're all or nothing. So take your time, get your 4 points for those questions. For questions 7 through 9, we're evaluating these expressions. Since they're just expressions, all you're going to do is find the change of base formula. Log of 343 divided by log of the base. Log 7. You're just typing this into your calculator. In this case, you get an answer of 3. I will tell you, on your test, if you write this portion out, so if you take the time and you write that out before you type it in your calculator and that part's right, Your answer's wrong, I'll still give you partial credit. So they're worth 2 points apiece. If you just give me an answer and it's not right, I can't give you any partial credit. If you show me what you're trying to type into your calculator and you just happen to hit something incorrectly, I can still give you one of those 2 points, which is better than nothing. So I highly, highly, highly recommend that you take the time to write out your change of base formula before you type it in your calculator. For the second one, we're going to take log of 2 divided by log of 8. You should end up with 1/3 or 0.3 repeating for your answer. For question number 9, you're going to take log of 1/81 divided by log of 3. Be careful, you've got 2 fractions all in one. You should get an answer of -4. So really just change a base formula for these, type them in your calculators to get your answers. Again, worth 2 points apiece. I can give you partial credit even if you have the wrong answer, if you have the correct change of base written down. Questions 10, 11, and 12, we are expanding logs. So at the bottom of your reference sheet, you're going to have the quotient, the product, and the power properties given to you to use to expand these. So looking at question number 10, we have log base 5 of a times b squared. Since it's multiplication here, we're going to use the product property to expand. When we expand using the product property, we use addition. Whoops. Which gives me log base 5 of a plus log base 5 of b squared. You cannot stop here. You've got to get rid of this squared. That squared goes down just in front of the log that it's attached to. So actually, my final answer is going to be log base 5 of a plus 2 log base 5 of b. That is your final answer. So nothing to compute for these. You're just expanding, stopping once you've checked. Question number 11, you have multiplication 3 times, so you're going to have 3 separate logs, log base 7 of x plus log base 7 of y squared plus log base 7 of z to the 4th. And just like the last one, we have these 2 exponents. Both of them need to move down in front of the log that they're associated with to get our final answer of log base 7 of x, that one doesn't change, plus 2 log base 7 of y plus 4 log base 7 of z. Notice I'm writing that base for every single log. Don't leave it out or forget it. You've got to write that base. And then question 12 down at the bottom, log base 8 of h to the 4th divided by w. In this case, we have a quotient, so we're using that quotient property. For this one, order matters. You're going to take logs of the numerator, h to the 4th, minus the same log of the denominator. So the denominator is always the second fraction, or the second log. One last thing, we've got this 4 as an exponent. It needs brought down out front. So 4 log base 8 of h minus log base 8 of w. Final answer worth 2 points for all 3 of them. 2 points apiece for all 3 of them. Questions on these 3? Moving on to questions 13 through 15, we're going to go in the opposite direction. When I go in the opposite direction, we're just condensing them down to one log. When you condense, the first thing you automatically look for are numbers out front of your logs. So you got to look for that power property first. In this case, 13 doesn't have any power properties to deal with, so you're just going to condense using the quotient property. So subtraction looks like a fraction bar. First log goes on top, second log goes on bottom. Just like that, final answer. There's really nothing else that you could write. Worth 2 points though. For the next one, we have to use the power property. So we have a 5 and a 4 sitting in front of our logs. So we're going to rewrite as 3 to the 5th power and x to the 4th power. And then again, we have subtraction. So we're going to combine them using division. So 1 log. Numerator comes from the first, which is 3 to the 5th. Denominator comes from the second log, x to the 4th. And you can leave that 3 to the 5th just the way it is. You don't have to compute 3 to the 5th. I'm just checking your skills on condensing. Then the last one, 15, the trickiest one here in this section, we got to take the 11 and move it up. That gives us this expression here. Here we have 3 logs, but they're all being combined with addition. So when I condense them, I'm going to use the product property 2 times. So I'm going to have log base 7, and then all 3 of these are just going to get multiplied together. Again, I don't care about the multiplication. I just want to see that you know they need to get multiplied. You can leave it like this. If it makes you feel better to write 12x to the 11th, that's perfectly fine as well. Questions on these? All right. For the next one, we did a question very similar to this one on the notes yesterday. Day before, a couple days ago. So we have an expression that we want to write as 1. In this case, we have both multiplication and division. We want to condense the first 2, the multiplication together first. Comes first, let's just do it first. So when I condense the first 2, there's no power properties that need to be followed. So no numbers sitting in front of the log. So I can just go ahead and combine those 2. 8 times x gives me 8x. I haven't done anything with the minus log of x minus 1, so I'm just bringing it down. Now I have 2 logs to condense, subtraction in the middle, which means I'm going to condense using the quotient property 8x divided by x minus 1. That is letter B. Looking at the next 4 questions, we're going to have 4 different log equations that we need to solve. So looking at the first one I notice I have 1 log on the left side, 1 log on the right side. These are my favorite because I can cancel the log base 17 on the left with the log base 17 on the right. Only cancel them when you have 1 on the left and 1 on the right. That gives us x squared plus 69 equals 17x minus 3. I notice I have an x squared, which means I'm going to have a quadratic equation to solve. I'm going to go ahead and move both terms from the right side to the left to get x squared minus 17x plus 72 equals 0. Going to take a moment to factor that. When I factor that, my a value goes in the top left, top right. That's 1 and 1. Negative 17, my b value in the bottom middle. And a times c, 1 times 72, or 72 in the top middle. Two numbers that multiply to give me 72, but add to give me negative 17. Negative 9 times negative 8. Therefore, that gives me answers, or factors, I should say, of x minus 9 and x minus 8. When I set both of those equal to 0, using the zero product property, I get solutions of x equals 9 and x equals 8. If I take a minute and quick check to make sure they both work, I can plug both of them in both of these parentheses and not get a negative answer. So I know they're both solutions. Looking at question 18. Question 18, I am not allowed to go through and cancel all 3 logs because there's 3 of them. I can only cancel if I have 1 on the left and 1 on the right, not when I have 2 on the left and 1 on the right. So the first thing I want to do is see if I can take these 2 logs right here and condense them. Well, there's subtraction in the middle, so I'm going to use the quotient property to put these 2 together. So using that quotient property, I now have log base 4 of the quotient x plus 5 divided by 12 equals log base 4 of 3. So I've taken those 2 logs on the left, I've condensed them. So now I have 1 log on the left and 1 log on the right. 1 log on the left cancels with 1 log on the right since their bases match. That leaves us with x plus 5 divided by 12 equals 3. I want to get rid of that fraction. To get rid of that fraction, you're going to multiply both sides by 12. That gives us x plus 5 equals 36. To get x by itself, we're going to subtract 5 from both sides. So x equals 31. Final answer. Question 19 is very similar to question 18. You have 2 logs on the left, 1 log on the right. The first thing you want to do is condense the 2 that are on the same side together. In this case, the 2 logs are being added, which means when I combine them, I want to multiply the 10 times the 7x. 10 times 7x is just 70x. The right side doesn't change. But now I have 1 log on the left, 1 log on the right. I can cancel those logs out, including their bases. Now I have 70x equals 29. I'm going to get x by itself by dividing by 70. And I'm just going to leave my answer as a fraction. 29 over 70. Looking at question 20. Question 20 is different than the last three questions because there's only one log. There's no log on the right side to cancel out, so I've got to have a different game plan for this one. So when we have one log, the easiest way to get rid of that log is to convert to exponential form. This is my base, this is my y, and this is my x. So I'm going to rewrite this as b to the x power equals y. Well, 3 to the 4th power equals y, which is 10n minus 9. I promise you, there's a question just like this on your test, and inevitably you students get stumped because they want to cancel a log out. And sometimes they do cancel a log out, but there's no log on the right side to cancel it out with. So make sure, I'm pretty sure it's question 20 on your test, you're going to convert to exponential form. You're not canceling anything out. And then just simplify this. 3 to the 4th power is 81. So 81 equals 10n minus 9. Add 9 to both sides. So 90 equals 10n. Divide by 10, and n equals 9. So really not that hard once you get past that initial step of rewriting it in exponential form, because your brain is converted to canceling logs out for the last three problems. You gotta watch it. So both of these were 3 points apiece. Question 21 says a function in the form y equals ab to the x power is called an exponential blank function when, keywords here, b is greater than 1. So if your b value is greater than 1, you have two answer options. Is this an exponential growth function or an exponential decay? Growth. There will be a question like this on your test. You're going to have to fill in exponential growth or exponential decay based off of what they give you right here. Question 22, we're going to sketch the graph of the following equation, y equals 4 to the x power. We always use the same 5 values when we have exponential equations. We're always using -2, -1, 0, 1, and 2. So what that means is in my calculator, I'm looking at this. In this case, it's a fairly simple exponential equation. 4, caret key, whatever number you're trying to type in. So 4 to the -2nd power, your calculator tells you 0.0625. 4 to the -1st power gives you 0.25. 0 gives you 1. 1 gives you 4, and 2 gives you 16. Then we have to graph these 5 points. So for me to graph -2, 0.0625, that's just going to be really, really, really close to my x-axis. 0.25, so -1, 0.25, just a hair above it. 0, 1 should be exactly at 0, 1, and 1, 4 should be exactly at 1, 4. I can't fit 216 on my graph. That's okay. So not always will you be able to fit all the points on your graph. Just know that that goes up all the way up to 16 before it gets to the second line for 2. And then remember on this left side here, the graph flattens out. It does not cross the x-axis. So you'll never get a negative value. If you just keep plugging in -3, -4, -5, you're going to get smaller and smaller and smaller numbers. It's going to get closer to that x-axis, but it'll never get to 0 nor cross it. So 2 points for this graph. Question 23, getting a little bit more complicated. Now you have 3 times 1/2 to the x power. We're still starting out the same way. We're going to start out by making an xy table. We're going to use those same 5 x values, -2, -1, 0, 1, and 2. But this time when we type them in, we're going to type 3 times 1/2 to the -2nd power. Your calculator will tell you 12. Then you're going to edit that -2, change it to a -1. Your calculator tells you 6. Edit the -1 to a 0 to get 3, then 1.5 and 0.75. So to graph these 5 points, I again can't graph -2, 12. My graph only goes up to 7, and that's okay. So the first point I'm putting on my graph is -1, 6. Then 0, 3. 1, 1.5. And 2.75. I'm going to play connect the dots off. So again, keep in mind, my graph is going to get really, really, really close to that x-axis as it continues, in this case, to the right, but it's never going to cross. What I'm really telling you is when you draw your line here, make sure that you don't go like this. Don't do this. So you want it to flatten out right along that x-axis. All right, so part A says explain whether this graph represents exponential growth or decay. So this is definitely decay. There's quite a bit of different answers you can have here. So you could just tell me that so decay because your B value is less than 1. Short, sweet. Part B is not on my screen, but it goes with this question, so we're going to throw it in here. Part B says, what is the y-intercept of the graph? Remember, your y-intercept's your initial value, or if you're looking at your table, it's just whatever order pair that goes with 0. So in this case, your y-intercept is 0, 3. So this question is actually worth 5 points. You get 2 points for your graph, 2 points for growth or decay, and then explaining why, and then 2 points for having, or no, 1 point, sorry, 1 point for having your y-intercept. Question 24 says a computer cost $3,400 in 1990, depreciated at a rate of 20% per year. How much was the computer worth 5 years after it was purchased? So this is going to be exponential growth or decay. Remember, y equals ab to the x power. A is our initial value. So our initial value in this case was $3,400. B is our growth or decay. Remember, when we have word problems, we have to calculate our growth or decay rate with the 1 plus or the 1 minus. In this case, our computer is losing value, it's depreciating, so we're going to use the 1 minus. Make sure in your test you're given a percent, you must convert it to a decimal, in this case 0.2. And then we were given a time frame of 5 years. So our exponent for our time is going to be 5. When you type this in your calculator, so the 3,400 parentheses 1 minus 0.2 to the 5th power, you're going to get a y value of $1,114.11. Same thing's going to happen on your test. You're going to pick the answer that's the closest. So letter A is only off 11 cents, so we're picking letter A. The same thing will happen on your test. I didn't write the test. I don't know who did, somebody from corporate, so I can't do anything about it. So pick the one that's the closest to the correct answer. Questions on this one? One more. So Lorena deposited $13,000 into an account that earns 3.5% interest each year. We're being asked to write a function for the amount in the account after T years. So this is just going to be a model. We're not given the years. We're just asked, hey, set this up so we can plug in 5 for part B. So y equals our initial value, 13,000. If we're earning money, we're going to use 1 plus 3.15% converted to a decimal is 0.0315. And our exponent, we don't know. T years is all it says. So we're going to use T for our exponent to represent the number of years that we're talking about. So that's it for part A. It's worth 2 points. Part B, also worth 2 points. How much money will she have in her account after 5 years? We're going to take the model that we just wrote in part A. We're going to take the time out because we were now given a time, and we're going to replace it with 5. We're going to type all that in our calculator. To find out that she would have approximately $15,180.62. So all that is a calculator problem plugging in 5 for T. Questions on this one? I'm going to have to scroll up to get to part C, so give me just a second. I'm going to copy that. So for part C, we want to know in how many years will her account exceed $25,000. So in this case, they're not giving you the time, they're asking you to find the time. So in this case, they're giving you the Y value, the amount of money they want in her account. So this time we're not replacing the T with 25,000, we're replacing the Y. And now we're going to solve for T. So to solve for T, we've got to first off get this set of parentheses that the T is attached to by itself. Fastest way to do that is to divide by what is being multiplied by, in this case, 13,000. Cancel those out. I'm going to be real lazy. On the left side, I have 25,000 divided by 13,000. I can cancel these 3 zeros out on both of them to simplify my fraction to 25/13. I think if you type that in your calculator, it's an ugly decimal, and you'd have to round it, and we don't want to round it yet. We're just in step 2. So then on the right side, I now have 1.0315. If I add those two together, to the T power. Once I get to here, I have an exponential equation. I'm trying to solve for that exponent. The only way to get that exponent out is to convert this to log form. So this is y, this is b, this is x. So I'm going to rewrite as log base b. I know this gets really ugly. So now I have log base 1.0315 of 25/13 equals t. We're almost there. Remember earlier, once you have a log with a crazy base, the only way you can figure that out is to use the change of base. So we're going to use change of base so that we can figure out what t equals just using our calculator. So log of 25/13 divided by log of 1.0315. That's going to give us t, or our time that it's going to take for her to have $25,000 into her account. You are going to have to approximate it. Remember, we're talking about years. If you approximate it to 21 years, that's fine. If you write 21.08, that's fine. If you get to 21, I'm going to be happy. So it definitely takes a few steps, but it is possible. If you get stumped or stuck on it, just raise your hand. Not that terrible.